Hi guys, please like, share and subscribe and contact this number if you want lectures related to any CM, CS or CB subjects. Thank you. Hello and welcome guys. So this is a question that we are looking at, and we'll first be looking at what's exactly happening here, and then we'll be going to Excel. Okay. Investors are allowed to choose how much they stake on a particular gamble. Okay. So like they have some wealth and they are allowed to choose how much that they want to stake or invest into a gamble. The outcome of the gamble is determined by the toss of an unfair coin. Okay, so it's an unfair coin that we're looking at in the following way. If the toss leads to a head, the investor's wealth is increased by the amount of their stake. So whatever is invested, okay, let's say an investor puts in one pound, their wealth will actually increase by £1. Okay, so that's like if it was 48 to begin with, 48 pounds, if they win, it will go to 49 pounds. Okay, and heads, investors' wealth will increase by the amount at their stake. Tails, the investors' wealth will decrease by the amount at their stake. So if they lose, or if it is a tails, okay, so let me call this as heads, this is tails, it will go to 47 pounds. If this is if they have put $1 at stake, £1 at stake. Okay, so stake is £1 in this case. Had they put £2 at stake, then things would look different. Okay, so if the stake was equal to £2, then this 48 would have gone to 50 on a victory. Okay, this is if they get a heads, and if it is a tails, that is if they lose, this will go to 46. Okay, so this is how it works, right? And the stake, whatever amount the investor puts at stake, is decided by the investor themselves, like what is the amount that you want to bet. Okay, assume that the probability of heads is 0.55. This is the probability of getting a head. So the coin is biased in favor of heads, that is, it is biased in favor of winning, right? And that would actually imply that in the long run, in 55% of cases there will be victories, and only 45% of cases there will be losses. Now, an investor has realized that by starting with a stake of £1 and repeating the gamble until they eventually win can result in a guaranteed profit of £1 if they double their stake each time the coin is tossed. So the investor will start with a stake of £1, and then at each toss they will just double. Okay, so next time it will be £2, the next time it will be £4, the next time it will be £8, so on and so forth. They'll just keep doubling no matter what the outcome is. And what is the goal that they are trying to reach? The goal that they are trying to reach is that they want to increase their overall wealth by £1. They want a guaranteed profit of £1, right? So they'll just stop when they get a guaranteed profit, or when they get a profit of £1, right? They'll keep on doing it, and like they'll do it perpetually, and finally they'll get a guaranteed profit of £1, so their wealth will just increase by £1. The investor is so convinced of this strategy that they're prepared to borrow money in order to execute it. So they can, like, just, you know, if they run out of their wealth, they'll start borrowing. So they want to perpetually keep on investing till they finally get a guaranteed profit of £1. Okay, the same investor has an initial wealth of £49 and a quadratic utility function which is given as this, where W is the level of wealth and D is equal to minus 0.005. Okay, so this is the question we are looking at. Now part 1 is calculate the investor's utility if they were eventually to win the gamble. What does eventually winning the gamble mean? That they will win this £1 that they are looking for, so their wealth just becomes 50. So you'll have to calculate the utility at the level of wealth 50, right? As just putting 50 into this equation will give you that. Create a table to calculate the stake that the investor would wager if the coin is tossed 10 times, each time resulting in a tails. So each time the coin is tossed, it results in a tail, right? That's the scenario we have been given. So the first tails, the second tail, so on and so forth. They're saying it keeps on coming tails 10 times, and the investor keeps doubling their stake as they have decided. So then what would the table look like, and what would be the amount that they'll put in, what will be their wealth at each level? That's what we want to see. So first let's just do these two parts. Okay, so this is very straightforward. So what is the value of D that we are looking at? As they have already told you, it's minus 0.005. This is obviously given in the format. Heads, what is the probability of heads? Probability of heads is 0.55. Okay. Now utility, the first part asks for utility if the investor eventually wins the game. So when the investor eventually wins the game, they get a guaranteed profit of £1. Their utility is 50. So how do you calculate this utility? It's simple. You just take this equation and you just substitute W as 50. So it will just be equal to 50. Okay, so it's W plus D W square. So 50 plus 50 square into D, which is this. Okay, so it's 37.50. This is the utility, right? So this is how you calculate this. Next, create a table calculating the stake that the investor would wager if the coin is crossed 10 times, each time resulting in a tails. Okay, so the first time the stake will be 1, and then it will keep on doubling. So it's 2. Okay, so every time it's double of the previous one. So what you can do is you can say equal to, you can take the previous one and multiply it by 2, right? And then this just gets filled downward. Okay, so just go to 10, select this and press Ctrl T. Okay, so this is how you calculate the stake. So what is happening is your stake is being doubled each time, right? Okay, now the next thing is we want to calculate the next part of the question. So we have calculated the stake that the investor is investing each time. They're just taking their initial investment of £1 and doubling it every time. Okay, that's all they're doing. Now create a table to calculate the stake that the investor would wager if the coin is tossed 10 times, each time resulting in tails. Okay, so this is done. The next part is calculate the investor's wealth and utility before and after each losing coin toss. So every coin toss they are losing, okay, because each time it's leading to a tails, as we have seen. Okay, so what is the wealth and the utility before and after each coin toss? Okay, so you have got the scenario for before and you have got the scenario for after losing, and you have to calculate the wealth and the utility, right? So what is the initial wealth that they are starting with? We were told it's 49. Okay, what is the utility? It's nothing, you just apply this function. Okay, so it will just be equal to the wealth. Okay, wealth, and then you so you take the wealth. Okay, and then you add wealth times dw square. So wealth square, so wealth square, and multiplied with the d. Okay, so this is 37, right? This is the utility. Okay, and now since they have put £1 at stake, their loss will be equal to whatever they have put at stake, right? So yeah, so their loss would be equal to this amount, and what would be their resulting wealth? It will be just be this wealth minus this loss. Okay, so it's 48, and then you can calculate the utility using this same formula. Okay, but instead of the initial wealth, you will be taking this G8 this time, right? Because you want to calculate the utility now with this wealth. So it's 36.48. Right, so this is how it works. Yeah. Now let's just keep on carrying this on. Okay. Next time, what is your wealth? It will be same as what your wealth was after losing, and what will be your utility? It will be same as what was your utility after losing. Okay. Then what is your loss? Now loss, in terms of loss, what we want to capture is, you can either capture the incremental loss, but since they are saying aggregate loss, what you want to capture is the total loss that the investor is suffering. So initially they suffered a loss of 1. Okay. Now they are suffering another loss. They're putting 2 at stake, and it will lead to a tails. So they will lose. So their total loss will become this initial 1 plus this 2. Okay. So their total loss this time will be 3. And their wealth will be initial wealth, which is fixed, minus the loss that they have suffered. So now their wealth will become 46. So this is how we are doing the calculation. Okay, I hope this is clear. So what I did was, first they put 1 at stake, so their loss was 1. Second time they put 2 at stake, so their aggregate loss becomes 3. That is the first amount they put at stake and the second amount they put at stake. So total loss is 3, right? Second loss was 2 and the first loss was 1. So the total loss is 3, and now they are left with the wealth of 46, which is the initial wealth minus the total loss that they have suffered. Let's also rename this and call this column as total loss. Okay. So that's how it works. And what is their utility? You can just like apply the same formula as the previous one. It's 35.42, and actually this can just be copied downward, right? So what you'll do is you will okay, so what you'll do is, now you can just replicate this formula. So let's just replicate this and replicate this. And now for this total loss, what will it be? It will just be equal to the loss, the amount we put at stake in the first gamble, we lost it. Second gamble we put in and we lost it. Third gamble we put in and we lost it. So it will just be the sum of these 3. Okay. So what I'll do is, I'll just apply a sum formula. Okay. And I'll do a sum of these 3 that I've selected, right? It's 7. And then you can just replicate this downward. Why? Because here the sum, here the loss will be equal to the sum of these 4. Okay, 1, 2, 4 and 8, because you put in all of these at stake and you lost all of them, right? So this is exactly B. Okay, but so this has taken B9 to B11. Okay, but we also wanted to include B8. So what I'll do is, I'll make this B8 fixed by pressing F4, right? Function F4, that's what I'll press, and once I press F4, this becomes fixed. This gets these dollar signs. Okay, now I can actually replicate this downward. Okay, so these numbers are correct. So this 15 is loss in the first 4 gambles. Okay, this 31 is loss in the first 5 gambles. So this is the total loss. Now wealth, you can just replicate it. It would just be the initial wealth that you started with minus the aggregate loss that you have suffered. Okay, so it will be these numbers. And utility, directly applying the formula on this wealth will just give you the utility. So yeah, this is your utility. Okay, so this is how you do these calculations. Let's move on. Okay, now let's look at the next part of the question. So it says, determine when the investor needs to borrow money in order to keep playing. Okay, when does the investor need to start borrowing? And this will be simple to determine, because the investor started with an initial wealth of 49. Whenever he or she runs out of the money, that's where they will borrow. Okay, so let's see. So your wealth after losing any gamble, let's just look at that. So here first 5 gambles, you can see it's positive. Okay, it's only after the 6th gamble, that the wealth has turned negative, right? So the answer is that when will the investor need to borrow? The investor will need to borrow after the 6th gamble, when their wealth goes negative. Okay, next one. Calculate the expected utility that the investor each time they have a choice to whether to play or not. Okay, so now the thing is, we want to find the expected utility of the investor each time they have a choice to play the gamble or not. Let's just see how will we do this. Okay, so in the first gamble, your wealth is 49. This is the initial wealth that you're working with, right? Now you either you play the gamble or you don't play the gamble. Let's say you play the gamble and you want to find the expected utility if you play. Okay, so if you play, if you win, your wealth will become 50. If you win, your wealth will become 50, right? Because you are putting 1 pound at stake, and if you win, you will get a wealth of 50, because you will win 1 pound from 49, you will go to 50, and your utility will be 37.5, right? If you lose, your wealth will be 48, your utility will be 36.48. Okay. So how do you calculate the expected utility? Expected utility will just be whatever the amount of money is that you make, or whatever is your utility when you win, into the probability of winning. So what is the probability of winning? Probability of winning is just the probability of getting heads plus whatever is your utility if you lose, multiplied with the probability of losing, that is the probability of getting tails, that is 1 minus heads. So this is your expected utility if you play. Let's get to the second scenario. Your wealth is 48. If you win, you get to a wealth of 50, because you are putting 2 pounds at stake. If you lose, your wealth will become 46 and your utility will be 35.42. So if you win, you get to 50 again, okay, and your utility will be 37.5, right? If you lose, your wealth will be 46, your utility will be 35.42. Okay, so again at winning, your wealth will get to 50, okay, and losing, your wealth will get to 46, okay, and this is the utility. Next one, if you are at 46, what is your wealth if you win? You are putting 4 pounds at stake, again it gets to 50. Okay, so you are seeing a pattern. Every time I win, even if I win once, right, I get to 50, no matter what my wealth is. If I lose, that's changing, the wealth is changing, right. So I can actually build an intuitive formula. So for the second one, you will see, if I win, I get to 50, my utility will be 37.5, the probability will be the probability of heads, plus if I lose, my utility will be 35.42, and probability will be probability of 1 minus getting heads, right. So we see a pattern, every time winning it stays same, it's always F3. So I can make this fixed, so I'll just press F4 and I'll make this fixed, and everything else just keeps on changing. Heads is obviously fixed. In the first one, I have H8, which is the utility on losing. The next one will be H9, the next one will be H10, so on and so forth. So I can just replicate this formula, okay. So let's just replicate downward, okay, till here, okay. So it's just the same formula. So this is your expected utility of playing. If you play, every time you win, your utility gets to 37.5, that is your wealth gets to 50. If you lose, that's variable, and this is your utility in the case you are losing, right. Okay, so this is how it works. Now the next one, use the result in 5 to determine when should investors stop playing the gamble according to expected utility theory. Okay. So as per expected utility theory, you will only play the gamble if it increases your expected utility from what it already is, right. That the utility of playing is higher than the utility of not playing, okay. That's only when you play the gamble. So when you're not playing, these are your levels of wealth. These are your levels of wealth before playing. If you don't play at any point, your wealth will be here, okay. If you do play, then this is your expected utility. Okay, this is your utility if you before playing, this is your expected utility after playing. You'll only play if your expected utility after playing is more than your utility before playing. So what I can do is I can check whether this is greater than this number. Okay, whether my expected utility on playing is greater than my utility if I don't play. So in this case it is, and you can check for all the cases. It's only after this point that you will stop playing. You'll only stop playing after this, right? You won't play in all of these cases. In all of these cases you will play. Why? Because here your expected utility of playing is greater than your existing utility. That's the idea. Okay. Explain why focusing on expected utility of only the next toss might not lead to the best outcome for the investor. See, the answer is simple. We know that in the long run the chances of winning are more than the chances of losing. Okay, this is something that we know, right? So eventually at some toss you are going to win, right? And then your utility, your wealth is going to go to 50 whenever you win. Okay, even if you like win here when you have already lost 1023 pounds, even if you win once, your wealth will directly go to 50, because here you are putting 462 at stake. Okay, when you are here, let's just say you are at 512, you have already a wealth of minus 462, so you are putting 512 at stake. Okay, if you put 512 at stake and if you win, then your wealth directly goes to 50, because that is 512 minus 462 is 50, your wealth directly goes to 50 even if you win once. Okay, your wealth will directly go to 50 and your utility will directly go to 37.5, right? So your chances of winning are higher than the chances of losing, and at some point if you go for like infinite trials, you will win at some point, and then you will have a higher utility, right? You will get to a wealth of 50, which is more than what you started with, and a utility of 37.5, which is something more than you started, and this is where you are trying to reach, right? We said that the investor eventually will stop as soon as they win £1, right? So it's a good idea to keep on playing and then eventually get here and stop, instead of just looking at the next gamble and the expected utility of the next gamble, right? So it's a good idea because the strategy is somewhat favorable if you keep on playing, and if you win just once, like you can lose 10 times further, but if you just win once because you are doubling your stake every time, you will eventually get here, which is where you want to get, and that's why it might not be a good idea to just look at the next gamble. That's the answer of it. So you can, if the investor persists with the strategy, they will eventually win and enjoy a utility of 37.5. So that's the answer. Okay, you can read the other answers here as well, right? So yeah.